When looking at motion problems, the main formula that you're going to rely on is that distance equals rate times the time. So think about it. You're going 15 miles an hour for 2 hours. So you went 15 miles per hour for 2 hours. Yes, that makes sense that you went a total of 30 miles. When you're setting up your motion problems, you're going to want to draw a picture. That often is very helpful. And usually your pictures will include two people or trains or something going in opposite directions. And then another setup is when you have somebody who travels and then and then a different person who's been like waiting around or napping or, then goes and chases up and catches up with him. As you can see on the left side, this is where the distance that this person travels and this person travels, it's different. These are going to be the type of problems where you add the distances. And usually they're going to ask you like how long until they're 220 miles apart or something like that. Right? And so that's going to be your skeleton equation is when you add your distances. Here, they are catching up. So, Joe goes to the right and then Sam catches up. So they both go the same distance. So this is different. It is not a sum. This is actually an equality. And so knowing both of these and setting up and having this picture in your head will help you tackle the word problems. So, Thomas leaves the amusement park, traveling at an average rate of 48 miles an hour. 2 hours later, Andrew realizes that Thomas has forgotten his wallet and drives off chasing Thomas at an average rate of 72 miles per hour. How long before Andrew catches up to Thomas? Okay, so Thomas is going to leave, and he's going to be going 48 miles per hour. Then Andrew is 2 hours later. So Tom has been traveling for 2 hours, and then suddenly Andrew's like, oh man, I gotta go catch up to him. And he's gonna catch up, and he's going 72 miles an hour. Makes sense. But while Andrew has been going super speedy fast trying to catch up, Tom is still diddly-dallying along at 48 miles per hour. You gotta realize Tom is still going. And then, as you can see, they will have covered the same distances. So the distance Andrew goes is the same distance that the distance Tom goes. So often you can set up a label box that will help you label your variables or define your variables. Rate, time, and distance. The reason why this helps you set it up is you can see rate times time equals distance. All right, now I know Andrew's rate, so I'm going to enter that. That's 72 miles an hour. And Thomas's rate is 48 miles an hour. Now the time is interesting. Let's call Andrew's time is A and Thomas's time is T. So because I have this in my label box, I don't need to write out A is the time Andrew traveled, T is the time Thomas traveled. But I will have to relate those somehow. Now, the total distance, I don't know that, but I know rate times time is equal to the distance. So this is 72A, and this is going to be 48T. So the distance that Andrew went is 72A, and that's equal to 48T. Now, how do I relate T and A? Well, Thomas was plugging along and was going 2 hours, and then kept going even while Andrew went. So if Andrew went for 3 hours, Tom had already been going 2 hours, so if Andrew went for 3, Thomas has already been going, so Thomas would go 5. So Thomas is always going to go longer, so Thomas is going to be Andrew plus 2. So now I have my two equations. I would go ahead and solve those, and I would be able to answer the question. So when I solve that, I get that Andrew takes 4 hours to drive, and so what that means is Thomas does 4 plus 2, so Thomas drives for 6 hours. So how long before Andrew catches up to Thomas? So it takes 4 hours for Andrew to catch Thomas. Now, how many miles will they have driven? Well, let's see. I could figure out how many miles Andrew drove by doing 72 times 4, or I could figure out how many miles Thomas drove by doing 48 times 6. Both of those should equal the same amount, and that's one way you can check it. So they will have gone both 298 miles. Let me just check that 48 times 6. 288 miles, 28, oh yeah, 288 miles. Good thing I checked. There we go. So here's my answer. And I did my check up here. Here is a situation where we have Dan and Namibia. They live 12 miles apart. Okay, so here's Dan. Here's Namibia. Dan is going to skateboard at 6 miles an hour. Oh, and Namibia, not Rebecca, is going to speed walk at 4 miles an hour. Now they lived a total of 12 miles apart. So how long will it take them to meet? Whereas before I had a distance of the first person equaled the distance of the second person, that is not what I want. Right now I want the distance that Dan goes plus the distance that Namibia travels, and I want that to equal 12 miles. So let's set up my rate, time, and distance in my table. We'll have Dan here and Namibia here. And so Dan's rate is 6 miles per hour, Namibia's 4. Let's see. If they leave at the same time, oh cool, so they both have the same amount of time. So Dan is going to travel 6 T miles, and Namibia is going to travel 4 T miles. So 6T plus 4T should equal 12. So they travel a total of 10 times T miles. So T is 12 tenths, or 1.2, or 6 fifths, or 1 1/5. Now it's hours. It doesn't make sense to say 1 1/5 hour. I do know that it is an hour and 12 minutes, because 12 times 5 makes 60. So that's how long it takes them to meet, because they both leave at the same amount of time. All right, when they meet, though, how far will each of them travel? All right, well, that'd be either 6 times 6 fifths, that's going to give me Dan, and 4 times 6 fifths will give me Namibia's distance. Notice Namibia, who went slower, travels a little bit less. Dan, who's skateboarded, travels faster. So Dan travels 36 fifths, or 7 1/5 mile. Namibia travels 24 fifths, or 4 4/5 mile. Now, what should these two add up to? Let me check. They should add up to 12 miles, because they started 12 miles apart. Do they? Yes, they do. Cool. Our most advanced type of problem has to do with current, or tailwind. When you are traveling downstream, one thing you should know is when you are going with the current, it's the speed of your boat plus the current. If you are paddling upstream or against the river, it is harder to paddle, okay? I used to lead canoe trips. So you're paddling and you're like, grrr, this is hard. Because you are paddling a certain speed, the same speed, but now the current is pushing against you. The same goes whether it's wind traveling with you or against you. So, the Concorde flies from New York to Paris. So New York to Paris always helps. With a tailwind, okay, woohoo, woohoo, so getting a boost. It completes this 4,650 mile trip in 3 hours, okay. 3 hours, and this is with the wind. On the return flight, going the same ground speed, okay. So I was going this ground speed with the wind. Now I'm going against the wind, so this is going to be my ground speed, but without the wind, or going against the wind. By the way, not exactly how tailwind and current and friction works, but we're going to go with it. All right, so Concorde flies into the same headwind. Okay, so that means it's like pulling it back. It's like, oh, this is so hard. The wind is going against me. And then it takes 4 hours. Okay, yeah, that 4 hours against. So what is the Concorde's ground speed? All right, well, this is interesting. Distance is rate times time. The distances are equal. It also told me it's 4,650. I need to define my variables. G is the ground speed of the plane. W is the speed of the wind. Sometimes it's making me go faster, and that's when I traveled for 3 hours. Sometimes it's going against me, and that's when I traveled for 4 hours. In both of those situations, I traveled 4,650 because New York and Paris did not change locations. They were still 4,650 miles apart. I took the same route. Hey, look at this. I just created a system of equations, and I can solve them. You might wonder, why didn't I just set these equal to one another? Okay, cool. So G plus W times 3 equals 4 times G minus W. That's right. In the previous problem, I was like, look, sometimes your distance going out and back is going to be equal to your distance, right? You're going to have a skeleton equation that looks like this. So why don't you set it up like this? Well, because you have two variables. So when you have two variables, you need two equations. And you at least have another piece of data in your problem, so you should probably use that. So go ahead and solve that out. I'm going to divide both sides by 3. So I could do substitution, I could do determinants, I could do linear combination. I think I'm going to opt for linear combination, so I'll multiply this by 4, multiply this by 3, I'll get 12G plus 12W equals 4 times 4,650, then 12G minus 12W equals 3 times 4,650. Watch this trick, I don't need to multiply this out. So now I'm going to add, and I'm going to get rid of these pieces. And so I'll have 24G equals, well, I have 4 4,650s plus 3 4,650s, so that's going to make 7 4,650s. And so now I am going to divide both sides by 24. So G, or my ground speed, is 7 times 4,650. I don't know why I'm making those so big. Divided by 24. So you could pull out your calculator, or you could try to just simplify that. I'm going to divide 4,650 by 4. So that'll be a 1, a 1. 25 will be a 6, and then 10. That's not working. Get 1,000. The ground speed is 1,356.25. So I was asked for the ground speed. That's all I need. Miles per hour. Was I in miles per hour? Miles, hours. Cool. There we go.